Hello class, welcome to the Igneous Rock Lab. Alright, so lots to cover here, but this is where the fun stuff begins. So, let's talk about igneous rocks. I would like you to open your lab manuals to said chapter, and we are going to begin by talking about the, we're going to set a baseline here and go back and talk about minerals again. And what I'd like to do is remember that a mineral is inorganic, okay? It has a defined crystalline structure and a defined chemical composition. So, why does this matter? For the purposes of this lab, we are going to be identifying igneous rocks. By the time we're done with this, you're going to be identifying it. And you need to know not only what you're looking at, you know, rock being an aggregate of minerals, you also need to know how these rocks were formed, because this is a very important part of igneous rocks. Okay, so the first thing we're going to do is we're going to talk about their formation. So igneous rocks are formed from volcanoes and magma that has extruded to the surface of the earth. Okay, so igneous means at its core a fiery rock. That's what this is. This is the very first stage of most rocks that we see. Okay, so when you have a volcanic eruption or magma that extrudes, which means that it comes to the surface and becomes lava, it eventually will cool. And when it cools, you will see different types of rocks will come out of this, depending on the way they cool. Where the magma cools, I will tell you that magma does not always cool at the surface. Sometimes it cools underneath the surface of the earth. So, when we see a volcanic eruption, or we see magma that comes to the surface, a lot of the reason that is driven by dissolved gases. Dissolved gases are such an important part of a volcanic eruption. So, most of the time when you see a volcanic eruption, what you're looking at is just tons upon tons upon tons of gases that have been thrown out of this volcano. Think if you were to take a Coke can and shake it up, and you open it up, and I don't know, go get your friend with it, I don't know. But what it will do is it will spray out. That pressure will be too much for the can to hold, and it will explode out of the can. Volcanic eruptions are much the same. This is a simplified example, but are much the same, where a volcanic eruption will throw out the magma and the gases into the atmosphere and onto the surface of the earth, and you will then have begun the process of the formation of igneous rocks. Okay, so we got formation down and dissolved gases. Okay, so how do we define what an igneous rock is, or how do we figure out what type of igneous rock you've gotten your hands on? Well, in your lab manual, you will see they start talking about the texture. The texture. Texture is very important. When it comes to igneous rocks, you have about 4 or 5 textures, might be 6. There are 5 textures. Yes. Okay. So, the first type of texture we're going to talk about is phaneritic. Phaneritic. So phaneritic essentially means large crystals. Okay, so to give you an idea, I have a piece of granite here, and you might not be able to see it too well, but I'm hoping that you can see that there's a large contrast between the crystals here, and you can actually see the different areas of color in these rocks. So phaneritic means typically, and they're called plutonic rocks because they sometimes form from plutons, that they cooled very slowly. They cooled very slowly, and a lot of the minerals had a chance to kind of congeal together. Okay, and the phaneritic textures tend to be very, very distinct and large crystals. If you look in your lab manual, you will see it will talk about a little bit of the Roman gods, how it was named for Pluto, and this is generally done intrusively. So that means that these most likely cooled inside the earth. Okay. All right. The next texture we're going to talk about is aphanitic. We already did phaneritic. is aphanitic. So aphanitic is usually signified by very small crystals. Very small crystals. Okay. And what this means is that you cannot pick out many of the individual crystals in here as you could with this piece of granite. This is rhyolite. Rhyolite is aphanitic and granite is phaneritic. And the aphanitic rhyolite has very, very tiny, almost imperceptible crystals. So, and that generally means that they cooled extrusively, which means that they got to the surface of the Earth and cooled very quickly, therefore not allowing the crystals time to congeal and come together, and that gives you these very even and consistent colors of rocks. Okay. The next thing we're going to talk about is glassy rocks. So you guys might recognize this large, very shiny, glassy rock. Some of you may know it as dragon glass, but in the scientific community, we just call it obsidian. And glassy, things that have a glassy texture, have cooled almost instantaneously. Almost like flash cooled, like just like that. Like they were ejected from the Earth and cooled immediately. This can happen in a variety of ways. It can be thrown up through the atmosphere, or it can be cooled by water. But typically, things that are glassy are extruded. Water is the most typical way for this to happen. And they will see that they're very shiny, very nice. All right. The fourth texture is porphyritic. Okay, so I know you really can't see this very well, but this sample of rhyolite that I've been holding is aphanitic, but it is also porphyritic. And this means porphyritic is what happens when you have larger crystals that cool inside of smaller crystals. So think of it like this. If you have a cookie, if you go to bake cookies, right? You'll actually see some mentions to baking cookies in these, which are kind of silly. But so imagine if you cooked it without anything in it. They were just basic, normal cookies, like, I don't know, sugar cookies, right? But then you were like, you know what? I want to throw some chocolate chips in there. That is basically what a porphyritic rock will be. It will be a rock that has a certain type of consistency, and then something else is thrown in there. And this porphyritic rhyolite is by far the most easy and simple way to see this, as it is a very light rock, but it has these almost peppery looking minerals inside of it. And that gives it a porphyritic texture. They're called phenocrysts. All right. And the last thing we're going to talk about is a pyroclastic texture. It's a pyroclastic texture. Okay. So this right here, this is an extremely light rock. I can very easily toss this back and forth. And usually what I'll do is hand this to one of my students and let them feel like it's going to be a very large clump of rock, and it's actually like super light, probably about the consistency of a sponge, actually. You can't like hold it and squeeze it, but it is extremely light, just like a sponge. This is actually pumice. So pyroclastic rocks are ejected very violently from the volcano and might cool as they fly through the air, but they typically have what are called vesicles. So if you look at this piece of pumice right here, you will see that it has these little vesicles running through it. All right. Okay, so now we're going to talk about the last part of this, and it's composition. Composition. Actually, I've not been crossing things off as I talk about them. The composition, when we talk about this, we're talking about the composition of the magma that has contributed to the formation of the igneous rock. And there are three types of this. The two that are most necessary for you to know, I am not going to ask you to identify an intermediate rock, are felsic and mafic. So think of it like this. Felsic rocks, they are high in silicon and low in iron. So when we talked about minerals in one of the last labs, you know that iron is a very dark, dense, very heavy material, right? But felsic magmas are very light, very light. So high in silicon, low in iron. That is felsic. So what you see here is they tend to have lighter colors. Lighter colors, so felsic rocks tend to be lighter. So that is, this piece of rhyolite that we keep coming back to is formed from felsic magma. But if you have mafic magma, are very high in iron and low in silicon. So here we have a piece of basalt, this giant igneous rock right here. And this basalt is, you can see it's very dark in comparison to the felsic rock that I have right here. And these are high in iron and low in silicon. All right. They tend to also be very dense and heavy. The intermediate magmas can sometimes cool somewhere in between. This is where we get into stuff like andesite, but I'm not going to ask you to identify a piece of andesite, as that tends to be very tricky if you do not have a chance to actually be tactile with the rock samples. So for your lab, all right, you will look, and I can assure you that the rocks I choose from this lab, the rocks that are chosen from this lab, will be in your lab manual. I'm going to ask you to identify a few of these samples, and I will ask you the composition, so you'll have to look at it and you'll have to say, well, that's either felsic or mafic. I'll ask you the texture, so you'll have to tell me the texture, whether it's aphanitic, phaneritic, and so on. You do not have to identify the rock. If you do not know the answer, or you do not know which rock it is, sit down and start working it out. So if you were to see this rock and you were to say, okay, well, this is obviously a very dark rock, so it is mafic. You know that it's mafic. And it's heavy, so that also lends to the mafic end. And you also see the small crystals. Small crystals. There are no individual crystals that you can see in here. You would know that it's aphanitic. Well, you're pretty much already halfway there. You've pretty much already given me everything I need to know. And then if you go into the lab mail and you're like, oh yeah, that's basalt, that would be it. But I'm not going to ask you to do the exact name of that. So, and also, be sure to note, I might ask you where the rock has cooled, so that will require a little bit of critical thinking about the size of the crystals. So if I ask you that, look into the size of the crystals, aphanitic, phaneritic, and so on. And that will tell us the answer there. So, good luck, and feel free to email your instructor if you need any assistance. And thanks for watching.